example, we're thinking about another quantity that's normally distributed. In this case, it is the number of fries in a basket of French fries. So you go to the restaurant, they don't count the number of French fries they're putting in. They just basically throw the number in that looks right, what makes up the right amount for that particular order. They're not counting each time. So there's going to be variation from one basket to the next. Some people are going to get a little bit more. Some people are going to get a little bit less. That's going to naturally determine a normal distribution over time, where there's some value in the middle that where most people get, and then there's some that get on the high end and some get on the low end. So in this case, we happen to know the statistics. We know that the mean value is 42 French fries and the standard deviation is 4 French fries. And we're supposing that we've heard from a friend, if you're in the top 5% of number of French fries in your basket, then the employee is probably flirting with you. They like how you look and they threw you a few extra fries as a little way to flirt with you. So how do we characterize the top 5%? Like how do we think about that? I've said before that everything about the normal distribution is determined once you know the mean and the standard deviation. So we need to be able to figure it out from those values. So let's think about the shape of the distribution and what is meant by the 95th percentile. So let me go back here to a picture. We'll go to this one. So we talked about the 68, 95, 99.7 rule. So this is the middle 95%. That's not exactly what we're referring to here. We want to be the 95th percentile. So that means we want 95% of the data to be below this value. So this says that 95% is between here and here. We want the value at which 95% of the data is to the left. So here, let's look at the normal distribution table or the standard score table, because that's what this table tells us. It tells us the percentile of that particular z-score. So if we want 95%, we're somewhere around here, right? So that's a z-score of like between 1.6 and 1.7. That would correspond to a 95 percentile. So back to this graph. We're slightly below the 2 standard deviation mark. We're somewhere like right here. That's about the 95th percentile. 5% above, 95% below. And then the z-score that we're looking for is somewhere between a 1.6 and a 1.7. So we will use that in our formula. Okay. So from the table, we don't know the number exactly, so we're going to estimate it just in the midpoint, 1.65. So we are looking for the value that corresponds to a z-score of 1.65. So z is 1.65. The mean value is 42, so that's the mean value of French fries is 42. Standard deviation is 4, so we plug that in as 4. We're using the standard score formula here and solving for x. So the steps, we need to get rid of the denominator, cross multiply by 4. So we have 4 times 1.65, gets rid of the denominator here, and that leaves x minus 42. So we add 42 to both sides, x will be by itself, and we have 4 times 1.65 plus 42 should give you 48.6. So 42 French fries is average. 48.6 French fries would be the 95th percentile. So if you've got 49 French fries or more, you're in the top 5%. And that's what we're looking for. That was the answer to our question. What does it mean to be in the top 5%? It means you have 49 or more French fries in your basket.